The chapter that we're doing is function operations. We're going to work today with the 4 basic operations: adding, subtracting, multiplying, and dividing. So really what we're looking at is what happens when you take 2 functions and add them together, or 2 functions and subtract them, or multiply or divide. This first one is addition. So it says sketch the graph of h of x, which equals f plus g of x. So given f of x equals x plus 1 and g of x equals x squared. So you're taking the function x squared and the function x plus 1 and adding them together. And that's going to give us this new function h of x, which I have just a screenshot here of where I did graph those, but I turned off h of x. There's actually 2 notations for f plus g of x. The one that I typed at the top, f plus g of x, or you could just say f of x plus g of x. Those mean the same thing. So what you see here, here is the same as this, is just another way of writing it. So you should have a pretty good idea of what f of x would look like, but it is graphed there for you. It's the purple line, x plus 1. So it's linear, it has a y-intercept of 1 and a slope of 1, which makes this purple line. And then g of x is just x squared. So it's that parabola, vertex at 0, 0. No horizontal or vertical stretch, just a regular old parabola. And down right here, you also see a table of values. So it gives you x values, -2, -1, 0, 1, and 2. And then the corresponding y values for the purple function and for the yellow function. What we want to figure out is what will the values be for y3, which is actually h of x. And this is how simple it is. For x equals -2, f of x is -1, g of x is 4, h of x is -1 plus 4. So it's 3. Which means if I want to, I'll do red because it's red function. If I want to plot a point, it's -2 and 3. So -2, 3. It's right there. You see that point that I plotted? -2, 3. Easy, right? So that's 1 point on that function h of x, which is the sum of f and g. So what will the next y value be in y3 right here? 1. 0 plus 1. So it's 1. Oops, that's okay. And then if I want to plot that point, where do I plot it? -1, that's the x value, and 1. -1, 1. So it's right there. I don't know if you can see that because make that dot a little bigger. Make it a little bigger. These are the ones that we're plotting, those bigger dots. The next y value, so we have f of x is equal to 1, g of x is equal to 0, h of x is equal to 1, because it's 1 plus 0. The next one is going to be 2, 1, 3. 2 plus 1 is 3. And then 3 and 4, so 7. And I'll plot the rest of those points. So I have a point at 0, 1. And I have a point at 1, 3. And I have a point at 2, 7. What kind of a shape is that making? Those points that I plotted. Did you say something? It looks like it's going to be a parabola, right? So if we go on over here, well, there are those points plotted. It says find f plus g of 4. Those are the points that we found, but what if I wanted to do another one? So what does that mean, f plus g of 4? When x is equal to 4. So let's put that into our table here. X is equal to 4. What's f of x going to be equal to when x is equal to 4? 5. X plus 1. 4 plus 1. What's g of x going to be equal to? 16, because it's x squared. 4 squared is 16. So then what's f plus g of 4? So it's f of 4 plus g of 4, which is 5 plus 16, which is equal to 21. Does that seem straightforward? And now we are actually showing that function after filling all those numbers in, joining those points together. And like you said, it looks like a parabola. Here it is. The next question is, write an equation for h of x. What is the function h of x? We know it's f plus g of x, but what's the actual function? H of x is equal to x squared plus x plus 1. Where did she get that? Just add the two functions together. One of them's x plus 1, one of them's x squared. Put them together, and you get x squared plus x plus 1. The next operation that I have here is the subtraction. So it says sketch the graph of h of x where the h of x is equal to f minus g of x. And then it gives you f of x and g of x. So the equation for that, f minus g of x, you would just take f of x, which is x plus 1. So this is what h of x equals. And then subtract x squared. So that's kind of a strange way to write the function. Usually we do descending order of the variable. So we'll actually rearrange that. H of x is equal to negative x squared plus x plus 1. Which is a quadratic function. It's opening down. So hopefully yours look like a parabola opening down. And you can see it right here. That's negative x squared plus x minus 1. If I did g of x minus f of x, g minus f of x, would that be the same as this? This one is f minus g of x. If I did g minus f of x, would it be the same or different? Different, right? But the first one we did was f plus g of x. If I switch that to g plus f of x, it would be the same, right? Because addition is commutative. If you switch around the order, it doesn't matter. Subtraction, it does. So just something to think about there. Here's the next one. This is f times g of x. So f of x multiplied by g of x. H of x is going to be equal to f of x, which is x plus 1, multiplied by g of x, which is x squared. I could expand that, because really that's kind of a strange form for it to be in, but it's useful in some ways. You could call this x cubed plus x squared in expanded form, either of those. And it's a cubic function, and you can see the red line there makes the shape of a cubic function. Hopefully that's, again, what yours looked like. The last one that I have up here is f of x divided by g of x. So for the equation, it's f of x, which is x plus 1, divided by g of x, which is x squared. That can't be simplified. I saw some people trying to cancel out an x and an x, but remember that only works for factors, common factors in the numerator and the denominator, not individual terms. So you have to leave it like that. And you can see that red line there. It's kind of a different sort of a function. Has an asymptote. Actually has a couple asymptotes. We're going to talk more about those functions in another unit. But hopefully you got something that kind of looked like that or was following that path a bit.